Okay, I want to calculate the Wronskian for these three functions. y1 is x, y2 is x squared, y3 is 5x squared minus 3x. I want to determine if these three functions are linearly independent. See if they form what we call a fundamental set. So I build my determinant. I list the three functions in the first row. Then I just keep taking derivatives. I have three functions. I need a 3 by 3 derivative. So I just keep taking derivatives until I have three rows. So I'm going to need first derivative, second derivative. If I had 7 functions, I would have the functions and then up to the sixth derivative to make it 7 rows. So derivative of x is 1, derivative of 1 is 0, derivative of 2x squared is 2x, derivative of that is 2, derivative here would be 10x minus 3, and then 10. Okay, I want the determinant of this matrix. So remember from pre-calc, finding the determinant of a 3 by 3 matrix, we're going to expand across the top row. So first we'll look at this element here, and in our minds we cross out the first row and first column and use these 4 elements left over and go these two minus these two. So x, write down that first element, times 20x minus 2 times 10x minus 3. Remember, it's always one way minus the other way. Okay, so that's our first element. We're expanding across the top row. Remember, it goes plus, minus, plus when you're doing a determinant. So now we'll have a minus x squared. So now this is my guy I'm using. We, in our minds, cross out that row and that column and use the 4 left over. And we go this direction minus this direction. So 10 minus 0. I'm multiplying these 4 objects. Going this way, 1 times 10 minus 10x minus 3 times 0. So that will be 10 minus 0. And then we move on to our third element in the first row. So now we're using this guy. Remember, it goes plus, minus, plus. Plus the first one, minus the second one, plus the third. So plus 5x squared minus 3x in parentheses. Parentheses are your friends here. Now, in our minds, we cross out that row and that column. And we use the 4 things left over and do a 2 by 2 determinant. This way minus this way. 1 times 2 minus 2x times 0. So that would be 2 minus 0. Okay, let's go ahead and clean this up a little bit. So let's distribute here. So negative 2x distributing here will give me a negative 20x plus 6. And then that 20x and negative 20x cancel out. So I just get 6x. From this next one, I get a minus 10x squared. And then distributing this 2, I get plus 10x squared minus 6x. Oh, look at that. Everything cancels and we get 0. So the Wronskian of these three functions is 0. That means these three functions are linearly dependent. So the Wronskian of these three equals 0. So they are linearly dependent. What that means is there are two ways to look at that. I can write one of these as a linear combination of the others. For example, y3 would be 5 y1s minus 3 y2s. If I take 5 times this guy, oh, I lied. 5 y2s minus 3 y1s. 5 times this guy minus 3 times that guy, I get this one. So I can write one of them as number times 1 plus number times the other. Or another way to say that is there exist constants C1, C2, and C3, not all 0. It's possible for us to find constants C1, C2, and C3 that make this equation true without making all of those 0. And it's obvious what that is. We could do, say, there are a bunch of different ways to do it, but I could say 3 y1s. What do we want? Plus 5 y2s. Negative 3 y1s plus 5 y2s minus 1 y3 must equal 0. So I found my C1, my C2, and C3 without making all three of those just 0. I have written these three as a linear combination equal to 0. So they are linearly dependent. So they do not form a fundamental set.